Alright folks, this lesson is on asymptotes of exponential and log functions. Okay, so we are looking at functions like this, or the exponential functions that we've been studying, but in terms of asymptotes and end behavior and all that we studied earlier in the year. Okay, so what you'll see on Delta Math, and this is like kind of intimidating I think, but it's just a bunch of fill in the blanks. Okay, I'm going to argue that this is looks more challenging than it actually is. I'm going to give you some notes to start to make sure that we know what we're talking about, and then we'll do a couple examples. Okay, so make sure you get good notes here so that we can tackle the examples together. Okay, so take a second to capture all of these now. You can just make bullet points. So some facts first of all. Log functions, so like our f in our example here, they only have a vertical asymptote. And that's because the inside of our log can't be negative, because exponents don't produce negative numbers, right? So there is only a vertical asymptote for these guys and no horizontal asymptote because they tend to keep growing forever. Okay. Exponential functions have no vertical asymptote, but on one side they usually have a horizontal asymptote. Okay, so right away when you decide whether something's exponential and log, and that's easy because it's given to you what it is, right? You can decide whether you're looking for a vertical or horizontal asymptote. So make sure you have this written down as a reference. You already know this, but increasing functions go this way up and to the right. Decreasing functions go down and to the right. Okay, so those are easy answers there. And then end behavior. We talked about this right at the end of last semester. End behavior on the left means as x approaches negative infinity. So that'd be like over here, negative infinity. And on the right means as x approaches positive infinity. Okay. These two things are the most important kind of new facts. So make sure you have those down. And then the rest of this is all kind of review. All right. Let's take a look at our first function here. So I will fill this out as if I'm doing the Delta Math, fill in the blanks so you can see what it should look like. So what are the features of the function graph below? Well, the first thing we need to decide is you'll pick between exponential or logarithmic. And this one is clearly logarithmic because it's got a log in it and no exponent in it. That's all it is. So you can look at the function. It would be harder if it just gave you the graph and you had to remember that this is logarithmic based on the way it looks, but you don't have to do that. Okay, so logarithmic, and then we need to pick vertical versus horizontal as this next box. Well, in this graph, you can kind of see that there's a vertical asymptote. Remember, it's the line that the graph does not touch vertically. And we can go back to our notes and we say that like log functions only have a vertical asymptote, right? Okay, so a vertical asymptote, and then we need to describe the line. So we're going to say, because it is vertical, we're going to say x equals 2. Okay, now the range of the function, remember that's the y that the y values that the function takes up. Well, it increases forever and decreases forever. So that's going to be negative infinity, infinity. Exponential functions will have a different range. We'll talk about that in a second. And this is increasing or decreasing. This one's increasing because it's going up and to the right. And its domain, here's where you have to do a little bit of thinking, right? The domain for a logarithmic function is going to relate to the vertical asymptote. Okay, so the domain is going to be from the vertical asymptote to infinity in this case, right? And if the function were on the other side, it would be from negative infinity to 2. Okay, so this is all stuff we've done before. We're just applying it to this log function. The end behavior on the left, well, this one's kind of interesting, right? The end behavior on the left, it doesn't approach negative infinity. It approaches 2 again. So as x goes to 2, y goes to negative infinity. Right? And we say 2 because of that asymptote again. The end behavior on the right is that as x goes to infinity, y goes to infinity. Okay, so it goes up and up and up forever. So something to note about these logarithmic functions is the vertical asymptote and the end behavior of the function is related. Okay, so one of your end behavior answers should include that vertical asymptote. So as x approaches 2, x equals 2 is my asymptote. Let's look at an exponential example. So here's an exponential function. We know that because it's got an exponential piece to it. X is in the exponent, right? No logs in this one at all. Okay, so we're going to answer all the questions on this one based on the graph as well. So the function f of x is exponential. And notice it kind of looks like it has a vertical asymptote here. But remember we said exponential functions have only a horizontal asymptote. Okay, so we're going to say a horizontal here. You can only pick one. Okay. This actually continues to the left forever. It just continues to the left very, very steeply, so it's hard to see. Okay. And you have in your notes that exponential functions only have horizontal asymptotes, so you should be okay there. The horizontal asymptote, so remember this is going to be a y equals equation now because the line is horizontal, and y equals -6 is that asymptote. Notice that shows up here, which is kind of interesting, right? The range of the function then is going to be from -6 to infinity. So that's the y values that the function takes up. And it is now decreasing on its domain of everything, right? -infinity to infinity. Okay, so it takes up the whole x-axis. The end behavior on the left side is as x goes to -infinity. Left side here, -infinity. Y goes to infinity, so it goes up forever. And then the right side, well, as x goes to infinity, y goes to, in this case, -6. Y goes to -6. Okay. So there's an exponential example. Remember, we know it's exponential because of the type of function that's given to us, not based on the graph. And then you can memorize that exponential functions only have horizontal asymptotes. Find it in the graph. That's going to be connected to the range of the function this time. So horizontal function and the range of the function are connected. And then the end behavior, notice that horizontal asymptote shows up one more time. Okay. If you need to see more examples, I don't want to give you a 20-minute video to watch. So if you feel like you need to see more examples, watch the Delta Math video that goes along with this one, and that should help you as well.